we are going to identify characteristics of quadratic functions. Okay, you might recognize this fella. This is our quadratic parent. Anybody remember the equation for our quadratic parent? Almost. One more thing. Squared. Okay, that's what makes it quadratic. Okay. Let's see what else we can remember about the quadratic parent. So look at the x values. I've got an arrow that goes forever to the left. I've got an arrow that goes forever to the right. I can trace my parabola without ever lifting up my pencil. There's no gaps or breaks. Do you remember the domain? All the real numbers. Okay, now looking at the y values, can I get any output down here that's negative? No. So is it going to be all real numbers for my y values, my range?
No, y is greater than or equal to 0.
Greater than or equal to 0. So we want y values that are 0 or bigger. Yep. Okay, where does this graph hit the x-axis? What are the coordinates of the point?
0, 0.
Yep. What about the y-intercept?
0, 0.
Exact same thing because it happens at the origin. Okay? If the intercept is not at the origin, then they can't really be the same anymore. Okay, so that's what we learned about the quadratic parent in Unit 3. We also learned how to do input-output tables, yada, yada, yada. I'm going to show you some graphing tricks to speed you up so that you don't have to use an input-output table, but we'll get to that in the next couple of days. More information about the quadratic parent function. So the quadratic parent in any parabola, really, this goes for all of them, has what we call an axis of symmetry. Okay? An axis of symmetry is a line that chops our parabola in half. So if I go okay, that is my axis of symmetry. I need you to do the thing. Help. Sound effects help. Yep, boop it up. Okay, so what this means is that if I were to reflect my parabola in this line, it would just land on itself. Does everybody see that? If I take this point and put it the same distance on the opposite side, perpendicular distance, it will land right there. Okay? If I do this point right here, it has its mirror image right there. So, I will tell you that if you can find the vertex of the parabola, which is right here, that's where our graph is going to intersect the axis of symmetry. Okay, that is the vertex. If you can find that vertex and like one of its arms, it gives you the same free points on the other side. Do you see that you really only need one of the arms? You need the vertex, and then you can use the symmetry to just be like, okay, well, if I have this point, then I got that point. If I get this point, I got that one. It's like buy one, get one. Okay, but you have to know where it turns, because if you accidentally like try to have this be the vertex and you do, that's not the axis of symmetry. Does that make sense? You have to actually know where the vertex is. Okay. So what is the axis of symmetry for this graph? What is the equation of this vertical line? X? Yes, it's x equals 0. Very nice. Okay, it's a vertical line. Okay, it's got X only. That is definitely the Riz. Okay, the vertex. Did I say something embarrassing? Okay, did I? Okay, embarrassing is fine. Did I say something I'm gonna get arrested for? Okay, okay. Just shameful, not illegal, is what I'm hearing. Okay, so my vertex is what point? What are the coordinates of my vertex? Yes, for the parent. Yep. Okay, the solutions. The solutions are the set of x values from the x-intercepts. So what is the x-intercept here? 0, 0. And what is the x-coordinate of that x-intercept? 0. So I take this 0 and I put it in curly brackets. Okay. If I had another solution, I would just list them separated by commas in the curly brackets. More on that later. Guys, I meant to put right here, I told you we were adding end behavior. I put it here, but I forgot to put it here, so we're just going to write it. It's short, it's not that bad. So, we have plenty of room. As x goes to, what order did I do it down here? I did positive and then negative. Okay, let's just stay with that convention. As x goes to infinity, f of x, okay, that's the y, is going to go to what? All right, well, as I let my x's get infinitely large, what are the y's doing? Where are the y's going? Yeah. How high? Infinitely high. So f of x is also going to infinity. That's easy enough, right? Now we're going to do negative infinity. So as x goes to negative infinity, f of x, the y, is going to well, it's going up also, right? It's not going to negative infinity, it's going to positive infinity. Okay, so that's basically what we've added. Easy, right? Like, where do the arrows point? No big deal, light work. All right, let's look at our first example. What is the vertex for this graph?
-4. It is 3, -4.
3, -4 is what we're looking for. Okay. The axis of symmetry is going through the vertex.
X equals 3.
X equals 3. Very nice. All right, now, the min or max value statement is not hard. It just tells you what the vertex is. So, yeah. So, I'm going to be in my vertex color. What happens when x is 3, do we have the highest value or the lowest? Okay, that's basically the min or max value statement. We say at x equals 3, because that's when it happens, we have a minimum of, how low does it go? How low does it go? -4. Okay, do you see that I just told you what the vertex is? Yeah. It's like I wrote a little sentence for the vertex. Here's a helpful thing. Do you see that this and this match? You see that? All right, what about the domain for this one? All real numbers. It goes forever to the left and the right, and I can trace it without lifting up my pencil. What about the range?
Y is greater than or equal to -4.
Correct. We want y values that are -4 or bigger. Do you see that that matches my minimum? Okay? If my minimum is -4, all the other y values should be -4 or bigger. Okay? Let's estimate some solutions. So my x-intercepts, it looks like, are 1, 0, and 5, 0. I want the x-coordinates of my x-intercepts. Pew, pew, pew. In curly brackets. I put them from least to greatest. So what is the first x-coordinate? 1, and the second one? 5. So those are the solutions. Why we call them solutions is going to make more sense after Christmas, but for right now you just need to know that that's what we call them. What? So we're solving quadratics after Christmas. So this is going to be graphing and characteristics and like doing some word problems and stuff. And then we will solve algebraically after Christmas. It's a beefy unit. It's a doozy. All right. See if you can do the end behavior by yourselves. What about when x goes to -infinity?
Y goes to
Yeah. If you said infinity, infinity, you are correct. Go straight to geometry. Do not pass go. No, you don't get to skip geometry. Okay. Oh, all right. One last thing we're going to do. Hey, 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 hey. All right. We're going to add arrows to this graph to show the intervals where our graph is increasing and decreasing. So I know that that arrow is pointing up, but remember that we read from left to right. So on this side, do you see that it's going down, down? Okay, and then it hits its minimum, and then what goes down must come back up. Good, good, good? Okay. All right, look at this guy. So we have our first application problem. Do I have an axis, a set of axes here? No. Where would it be helpful to put the axis, do you think? Where do you think it would be helpful? Would I want to put the axis like this? Okay, where could I strategically put it to make my life easier? At one of the corners? Can you want to show me what you mean?
like you use one of the
Like,
2 lines to make.
okay, I'm being deliberately obtuse. Like this?
Yeah.
No, you use the top left or the bottom.
Okay, now we're getting somewhere. So if I make these my axes, do you see how this problem gets a lot easier? Okay, perfect.
Oh.
Everybody see it?
Yeah.
Now my entire graph is in quadrant 1. Here's quadrant 1. Here's quadrant 2. Here's quadrant 3. Here's quadrant 4. Okay, so what are the coordinates of this point where my ball is starting to bounce? Okay. Okay, now because of where Chase told me to put my origin, what are the coordinates of this point where my ball hits the ground again?
0,
Close?
5, 0.
5, 0. Okay, how high does my ball go? Okay, is that going to be the x or the y coordinate of my vertex? The y, because it's the height. So my height starts at 0, it goes to 3, and then it comes back down to 0. Does that make sense to everybody? Okay, now here's the exciting part. You remember my axis of symmetry, right?
Yeah.
It chops my parabola in half. So how far to the right is my x-coordinate?
2.5.
How did you get that?
Because half of 5
Okay, sorry. sorry. Maybe I didn't sleep so good last night. I got like 2 hours of sleep. Okay, everybody happy with this picture? What's my vertex? Okay, what's my equation for my axis of symmetry?
X equals
I feel you wanting to say 3, but you know it's wrong. What is it?
2.5.
It's 2.5. Good.
Yes.
Yes. All right, min or max value statement. So, do we have a min or a max?
Yeah.
Okay, where does it happen when x is what?
They're very top. So it's a max
5.
of
Yeah. So at x equals 2.5, we have what happen?
Max.
A max of 3. That's our maximum height. Ooh, well, is it?
no.
Do I have arrows to say that this graph goes on forever? Does my ball go shooting through the core of the earth and out through Australia?
That'd be pretty cool.
It would, but it doesn't happen. Okay? It would not survive the molten core. So, my domain is a little bit more complicated. I'm going to do this in green. Domain is my x values. What is my smallest possible x value? 0. What is my biggest possible x value? 5. So do I really just want all the x's from 0 to 5? That's what I want. I'm going to make a sandwich. So my x's have to be
0.
sandwiched. Whoops, I wrote 0. Sandwiched between 0 and 5. I want 0 to be less than or equal to x, which is less than or equal to 5. All right, now you have an example for the domain. I want you to do the range. Make sure that you don't go from greatest to least. Make sure you go from lowest y to highest y.
Yes, ma'am.
Thank you. What is the lowest height for the ball if it hits the ground? Okay. And the highest y? 3. So notice that in the domain and range, I don't need to necessarily mention the 2.5 at all. Unless, yeah, whoops. Yeah, I don't need it at all. Okay, estimate solutions.
Probably like
I need the x coordinates from my x-intercepts in curly brackets. What are they?
0 and 0. 0 and 5.
0 and 5. Least to greatest, separated by commas. Okay, you ready? Flip, flip. All right, this is going to be faster. All right, I don't know much about football. Someone else made this problem for me. The kicker for the Capital City Cavaliers football team starts the game by sending the football a maximum height of 25 yards. That's high. After flying a horizontal distance of 60 yards. Assuming that the football is kicked from 0-0, sketch a picture of the football's flight path and identify the key characteristics. Now, have you guys noticed that every projectile is going to follow a parabolic path? So this unit is going to be full of projectiles. That's going to be what we talk about all the time. So, where is my ball kicked from? 0-0. Ew. I can do a better parabola than that. Okay, where should I put my axes so that it's convenient?
Probably like 2 minutes.
Yeah, probably through the middle. Okay, here's quadrant 1. Here's quadrant 2. Here's quadrant 3. Here's quadrant 4. My flight path is starting at 0-0. How high is my maximum height? 25. Is that the x value or the y value of my vertex? The what one? The y. So I put the maximum height as my y coordinate. Okay. How far horizontally did my ball have to travel to reach that maximum height?
30 yards. Well, like, I meant 60, but like, I had
60.
What?
Wait.
I don't.
It reaches, it's like at 60 yards horizontally, it reaches its maximum height of 25. Do I need to go back and talk about it?
I'm good.
So does it say it flew 60 yards total horizontally?
No, that's what I saw.
Do you hear the difference?
Yeah.
Okay, so if I put my axis of symmetry on this bad boy, and it's 60 on this side, what is this side going to be? Also 60, which makes my, how far did it travel? Yes. So this is the point, 120 yards, 0 yards. Everybody got it? All right, what's the vertex? 60, 25. Axis. Do you guys want to try doing this on your own? Axis of symmetry? Okay, I'm hearing people say 60. Do we say equations as just a number? X equals 60. Thank you. I thought I was going to have to start screeching like a banshee. All right, go ahead and write the min or max value statement. Okay, so you have to be careful because the maximum height isn't necessarily the biggest number in the vertex, because it could have traveled farther horizontally than vertically, right? So you have to make sure that you make your max your y value. This is a y. Your max has to be a y value. Okay? If it helps you to label the 25 on the y-axis, do it. Okay, then you can be like, okay, the height is 25. The max height is 25. Everybody happy?
Yes.
All right, domain.
0 is less than or equal to x, which is less than or equal to 1.
Good. Okay, everybody do the range. Okay, check yours with mine. Okay, solutions. Good. X coordinates of the x-intercepts. So this 0 and that 120. Oh, geez Louise. So now we have to match the number of real solutions. Okay, so do you guys see that the solutions just correspond to the number of times that our graph is hitting the x-axis? Because we get our solutions from the x-intercepts, right? So number of x-intercepts equals number of real solutions. Okay. Write this down. Okay, so we're going to draw some little sketchy poos so that we don't have to do all of this in our brain. So, I want the graph of a quadratic that opens up and has its vertex at the origin. So, I'm going to draw a little set of axes. Okay, which way does my parabola open up? Like a cup or down like a frown? Up like a cup. Okay, so it's going to have that positive a value. And where's its vertex? Origin. Okay, so I'm going to make a little sketch just like that. How many times does this picture hit the x-axis? Once. So how many real solutions will it have? One real solution. Easy, right? All right, the next one says that it opens down and it has a vertex in the first quadrant. Okay, I'm going to draw my picture. Here's quadrant 1, 2, 3, and 4. Where is my vertex? Quadrant 1. Which way does my parabola open? Down like a frown. How many times does that graph hit the x-axis? Good. 1, 2. So how many real solutions will this have? Good. Okay. Graph opens up and has a vertex at 0, 2. Let me get my sketch. 0, 2, is that up or right from the origin? Up from the origin. And it opens up like a cup. Is that graph ever going to touch the x-axis? No, because its minimum is floating above the x-axis. So this has no real solutions. Okay, everybody see the options? It's either going to hit once, twice, or never going to get it, never going to get it. Okay, we've kind of already done this a little bit, but we need to firm it up before we move on. We need to select the word that best completes each statement, and then we're also going to do the end behavior. So the domain is talking about the x values. So on the part of the graph where the x values are less than -2. So that's on this side of the graph. Is my function increasing or decreasing? So remember, we're reading from left to right. Pretend this is the path of a ball. Yeah. So my height is increasing, increasing, increasing till it reaches a maximum and then goes down the other side. So I'm going to say increasing. Okay, on the other side, when x is greater than -2, what is happening to the value of my function? Decreasing. Okay, I want you to do the end behaviors. This is our, this is exciting. Okay, as x is going to positive infinity, what is happening to the value of my function? It's plunging down toward negative infinity. It's our first negative infinity. All right, what about if x goes to negative infinity? What's happening to the value of my... It's also going to negative infinity. So fun. All right, can you do example 6 on your own? Try it. Okay, when x is less than 4, so to the left of 4, what is happening to my function? Good. All right, what about when x is greater than 4? Increasing. And then my end behavior, what's happening as x goes to negative and positive infinity? What's happening to my f of x's? Pew, pew, pew. Yep. Okay, that's the end.